Hello, everyone. So, a lot of times, what I've observed is people are a bit reluctant to start with their Gmat prep because they feel they haven't done any question related to math or quant in a very long time. And they say that maybe a refresher of the basics can make them feel familiar. So, I decided to create a series of videos which will help you become comfortable with fundamental topics like ratio and percentage, taking LCM, how to solve linear equation, how does quadratic equation works, what is inequality, what kind of number system do we deal with, what are exponents. All this knowledge will make you feel very comfortable when you dive into proper GMAT study mode. So this is supposed to help people who are feeling a bit of inertia before starting their GMAT prep. I hope I do justice to clarify all the fundamental concepts. Remember, this series is only for fundamental concepts. All the concepts that we will build over it will be covered when we get into GMAT theory in depth. But this is just a basic. It's like testing the waters to make you feel comfortable of the journey in front of you. So I hope you enjoy this video series. I will basically start with classification of numbers. Let me just pull up the whiteboard and let's make it black because I like dark mode better. So why does classification of number matters? Again, it's all about being familiar. There's nothing more to it than just getting familiar with it. So let's just quickly understand in how many ways are these numbers classified. And if I talk just about the numbers that we use, the first thing that we need to know is that we operate on the decimal system. The decimal system is the system which has numbers from 0 all the way till 9. So decimal system has 10 numbers. And after 9, you will start getting two-digit numbers, which is basically 10, 11, and 12. Now, I like to classify it in two broad categories where I say there is no fraction part. So basically, numbers with no fraction part are the kind of numbers which will have 0 after the decimal. So 7.0, 85.0, and numbers with fraction part. First, let's understand the numbers which have no fractional part. The first classification is natural numbers. Now, natural numbers are basic counting numbers, and it's something you can count on your fingers. So 1, 2, 3, 4. That's why natural number starts from 1 and keep on going further. Second broad classification is whole numbers. Now, the difference between whole numbers and natural numbers is that whole number also includes 0. So all natural numbers plus 0 constitutes whole numbers. And the third category that comes in here, let me put this in center, is integers. Integers are all whole numbers plus negative numbers. So minus 10, minus 5, minus 3, 0, 1, 5, 15, 85, 68, so on. So all these numbers are called integers. Now, just one very important thing that you should know is whenever a question ever says non-negative integers, it basically, whenever the word non is used, I need to take all numbers which are not negative. So it will always include 0 as well because 0 technically is not negative. So it will be 0, 1, 2, 3, 4, 5, and so on. Similarly, if it says non-positive number or non-positive integer, that means all numbers which are not positive. Again, you will have zero because zero is neither positive nor negative. 0, -1, -2, -3. So this is one thing you need to be careful of. And I think what is a positive number and what is a negative number is something that is self-explanatory. So I didn't need to get into details of all of that. This is the classification of the numbers which have no fraction part. Now, from this, I get definition of the kind of number which is called rational number. A rational number is the kind of number which can be written in the form of P upon Q, where both P and Q are integers and Q is not equal to 0. So any rational number is a number which can be written in the form P by Q, where both P comma Q are integers and Q is not equal to 0. We'll circle back to this, but I just wanted to introduce the definition of rational numbers because the only thing you need to understand the definition of rational number is integers. And now we understand integers. Integers are all whole numbers and numbers with negative sign as well, and no fraction part. Now, if I come to fraction part, there is two broad categories. One is terminating and another is non-terminating. Now, if a number is terminating, that means its fraction part terminates at some point. So a number like 7.53 falls into that category because it's ending at 3, or a number like 6.5 also falls into that category. Now, because we know the system that we use is a decimal system, if we know that the system that we use is a decimal system, this 7.53 can be written as 753 by 100. And this 6.5 can be written as 65 by 100. So in the denominator, we take as many zeros after 1 as our numbers after the decimal point. So for 6.5, I will do 65 by 10. 7.53, I'll do 753 by 100. So we get one very interesting thing with terminating numbers. All terminating numbers will only have powers of 10 in the denominator. Now, from that 10, something might get cancelled with the numerator. Like, let's say, for example, if I have to simplify this, both numerator and denominator are divisible by 5. So I can write it as 13 by 2. But still, in this, even after cancellation, denominator only contains powers of 2 and 5. Or and is not the right word here. So 2 or 5 or both is a better way to say this. So if the denominator has any other number except for 2 or 5 or both, then in that case, the number in general will not be terminating, which we will come to. We will come to non-terminating numbers. And why only 2 and 5? Very simple, because 10 is composed of 2 and 5. So because 10 is composed of 2 and 5, and as we saw in one example, that one of the 2 or 5 or any power of 2 or 5 might get cancelled with the numerator, that means the denominator should be only containing powers of 2 or 5 or both. That's only when that number is terminating. Now, if I come to the non-terminating category, so non-terminating category is something that keeps on going, like the decimal part, the fraction part, just keeps on going and going and going. So a number like 3.33333333, these kind of numbers, or let's say 6.151515151515, and so on. These kind of numbers are called non-terminating, and repeating. Now, because they are getting repeated, there is a pattern on the fractional side, which is even though going till infinity, but because there's a pattern, there's a way to cancel it out. So 3.33 can be written as 10 by 3. If you want, you can start dividing 10 by 3, and you will see that you will keep on getting 3.33333333 till eternity. Now, if you want to challenge yourself, try to find out how we will write 6.1515 in its rational form. So try to do this by yourself. How would the rational form of this number look like? So in non-terminating, we have the first category, which is non-terminating and repeating. And second category is non-terminating, non-repeating. Non-terminating, non-repeating numbers are the kind of numbers where the fraction part doesn't show a pattern. So if I write pi in fractions, it will keep on going from 3.14, and scientists are still discovering the values of it. Some computers are able to guess pi till millionth decimal and all of that. The reason for that is because there is no pattern in the numbers that come. Another irrational, these numbers are called irrational numbers. So, and another irrational number here is root 2. And of course, irrational number is something which is opposite of rational number. So irrational numbers are the kind of numbers that cannot be written in the form of p by q, where q is not equal to 0 and p and q are integers. So these numbers are irrational numbers. Which numbers? Non-terminating, non-repeating. Every other number that we studied, which is non-terminating and repeating, terminating, natural numbers, whole numbers, integers, all of this category broadly falls into rational numbers. So now if I classify, you have this category of numbers called real numbers. And what are real numbers? Numbers that can be represented on the number line. Real numbers have two broad categories. One is rational numbers. So rational numbers has integers, terminating decimal, non-terminating, non-repeat, non-terminating and repeating. And second category is irrational numbers. Irrational numbers basically are non-terminating, non-repeating. So this is a broad classification of numbers that we can do. Apart from this, two major classifications that we will just introduce. Like I said, the purpose of this video is to just introduce you to certain concepts that might make you feel comfortable when you're doing a full session of quant theory with anyone. It's not about you're doing it with us. This will make you comfortable with full session of quant theory with anyone. So another two broad category of classifying numbers, and this is majorly focusing on whole numbers per se, or you can say integers, is number one, odd and even. How do we classify odd and even numbers? We check divisibility with 2. If a number is divisible by 2, then the number is even. And if the number is not divisible by 2, then the number is odd. So even number basically become 0, 2, 4, 6, 8, and so on. And odd number basically become 1, 3, 5, 7, 9, 11, 13, and so on. So basically, even numbers and odd numbers fall into these two categories. Next, before we move to the next category, we need to understand that we should know how operations with odd and even will give different result depending on what are the inputs. Like say for example, odd number plus even number will always give you odd. Even number plus even number will give you even, and even number times even number will also give you, not times, plus, I beg your pardon. We'll come to that. Even plus even will give you even number, and odd plus odd will also give you even number. Now, you can try this by just taking random numbers. Take like one even number and one odd number. This always applies. When it comes to multiplication, odd into odd will always give you odd. Even with odd will give you even, and even with even will also give you even. So this is broadly everything you need to know about odd and even numbers. And there are some very interesting questions that are built over this. And that is something we discuss when we cover the full theory. But this will make you feel comfortable when it's explored. Next category that you should know is prime numbers and composite numbers. And this is the last section for this video, which is what are prime numbers and what are composite numbers. See, there is this thing called factors. Factor is a number which can divide the number in question. Like say for example, we talked about 10. So what are factors of 10 if we have to explore? What are the numbers that can divide 10? We already know 2 and 5 because 10 can be written as 2 times 5, and there are two more numbers. 1 can of course divide any number, so that's why 1 will be a factor of 10. And the number itself can divide any number, so that's why 10 will also be a factor of 10. So 10 has four factors. This is what a factor means. Factor is a number which can divide the number in question. Divide means when we are dividing with it, the remainder is zero. So I'll try to like go as basic as possible. Now, prime numbers will only have two factors, which is 1 and the number itself. And composite factors will have greater than two factors. Sorry, composite numbers will have greater than two factors. Like the number 10 that I took, 10, 18, 36, 25, 6, 8. All these numbers are composite because they can be divided by more than two numbers. And what are prime numbers? Smallest prime number starts with 2, and 2 is the only even prime number. Sometimes interesting questions are built on this concept that 2 is the only even prime number, followed by 3, 5, 7, 11, and the list goes on. It's a good idea to remember prime numbers till 50 or 100. It sometimes helps you. So, just to summarize, we understood what are real numbers. Real numbers are the numbers that can be represented on the number line. A number line is a one dimensional line which goes from plus infinity to minus infinity with the center at 0. So any number that can be plotted on this is called a real number. And real numbers have two classification. One is rational, another is irrational. Rational numbers are the kind of numbers which can be written in the form of p by q, where both p and q are integers. And irrational numbers are the kind of numbers which are non-terminating, non-repeating. Like pi, we are still finding decimal values of pi. Moving on, the second classification which is necessary is knowing odd and even. Odd and even has to do with divisibility of 2. If by dividing 2 we get a remainder as 0, then the number is even. If we divide it by 2 and we get the remainder as 1, then the number is odd. We need to know what happens if we add odd or even numbers and multiply odd or even numbers, and that's something you can see on the screen. And finally, we understood what is prime number and composite number. One very important thing that you should always remember, 0, comma 1, these two numbers are neither prime nor composite. And you can think a little if you want to challenge yourself, just think a little as to why. Now, in this video, if you go in the description, you will find a PDF which contains some basic questions which you can answer to get a better grip on what we just studied. Again, numbers like composite numbers, how many factor does a composite number have? These are little moderate to advanced questions that we will anyway cover in theory. Please remember the objective of this session is to just cover the basics so that you feel comfortable. You don't feel weird when I say something like, oh, this is a prime number, this is an even number, this is integer, this is whole number, this is rational, this is irrational. You just know the definition so that you don't feel lost when any kind of these words are introduced in the classes. So I hope you enjoyed the video. If you enjoyed the video, please like it, comment on it, and thank you so much for listening to it till the end.